Hey tech enthusiasts! Ever wondered what makes the latest AI models so incredibly powerful? Today, we're taking a peek under the hood and comparing two key architectures, the trusty transformer and the exciting mixture of experts, or MO. These are the brains behind many cutting-edge AI systems, and understanding their differences is super fascinating. Let's dive in. On the left, we have the classic transformer architecture. This has been the workhorse for so many amazing language models. You feed in your inputs. Let's imagine these are words in a sentence, represented as colored blocks. First, we have positional embedding. Remember, the transformer needs to understand the order of these words, so we add information about their position in the sequence. Then, the data goes through these decoder blocks, and there can be many of them stacked on top of each other, indicated by the decoder block *n. Inside each block, we see a few key steps. There's layer norm, which helps to stabilize the learning process. And then we have masked self-attention. This is where the magic happens. The model looks at each word in the input sequence and figures out how it relates to all the other words in the same sequence, but it's masked, so it can only look at previous words when generating the output. This helps it understand context. The results of the attention mechanism are then combined with the original input and go through another layer norm. Next up is the feed-forward network. This is another layer that helps the model learn complex patterns in the data. This whole process within the decoder block is repeated many times, that's the *n, allowing the model to refine its understanding and generate the final outputs, maybe the next word in the sentence, or a translation. Now, let's look at the right side, the mixture of experts architecture. You'll notice it looks very similar to the transformer at the beginning. We still have inputs and positional embedding. We also have decoder blocks with layer norm and masked self-attention. But here's the crucial difference. Instead of one big feed-forward network, in the mixture of experts, we have multiple smaller, expert, networks. And there's a router. The router's job is to look at the incoming data and decide which of these selected experts are best suited to process it. It's like having a team of specialists, and the router directs each piece of information to the expert who knows the most about it. Each of these selected experts then processes the data, and their outputs are combined, often through some kind of weighted averaging, to produce the final output of this part of the decoder block. Just like in the transformer, this MO decoder block can also be stacked multiple times, *n, to build a deeper and more capable model, eventually leading to the final outputs. So, what's the big takeaway? The standard transformer uses one large feed-forward network to process all the data. The mixture of experts, on the other hand, uses multiple smaller, specialized expert networks, and a router intelligently directs the data to the most relevant experts. So, there you have it. Transformer versus mixture of experts, two powerful architectures driving the cutting edge of AI. Thanks for watching.